All right, so in this video, I'm going to talk you through 3 panels of the whiteboard. So what I encourage you to do with each panel is to pause it and copy this down, and then press play and copy out while I work through these problems. All right, so we're going to start with a fraction review. I'm going to add, subtract, multiply, and divide 2 fractions. Now, one of the interesting things about fractions is that it turns out that multiplication and division is much easier than addition and subtraction. So the first case here, I have 3/8 times 4/9. And so with multiplication, I get to multiply the top times the top and the bottom times the bottom. And this would get me to 3 times 4 is 12 on top, and 8 times 9 is 72 down below. All right, now that is an answer and it is correct, but it's not in the simplest form. Okay, there are numbers that I can divide both 12 and 72 by. In fact, 12 goes into 72. So I can view 12 as 12 times 1 and 72 as 12 times 6. My 12s cancel, and I then get a reduced, really nice answer of 1/6. I could have also seen that earlier on. So if I quickly redo the problem, 3/8 times 4/9, I could have done some canceling. A 3 and a 9, I could divide 3 by 3 and 9 by 3. And 4 and 8 both are divisible by 4. So if I divide 4 by 4, I get 1. If I divide 8 by 4, I get 2. And then 1 times 1 leaves me with a 1, and 2 times 3 leaves me with a 6. So I can either simplify right off the bat and then multiply top by top, bottom by bottom, or I can multiply first and then simplify after that, okay? All right, now division works very similarly with one caveat. When I divide by a fraction, it's the same as inverting it and multiplying it. So inverting it would mean taking 3/14 and writing it as 14/3, okay? All right, and now I'm back to a multiplying 2 fractions problem. I'm going to simplify first and then multiply. 3 goes into 3 once, 3 goes into 6 twice. 7 goes into 7 once, and 7 goes into 14 twice. So I've simplified this to 2/1 times 2/1, and that gives me 2 times 2 over 1 times 1, which is better known as 4. Okay. All right. With addition and subtraction, I have to first get a common denominator. All right. So the 2 fractions have to have the same denominator, the same bottom number before I can add or subtract. So with 6 and 8, a common denominator, I could always multiply 6 by 8 and use 48. That could be overkill. So for example, I think 24 is the smaller common denominator. So if I multiply 6 by 4, I'll get a 24. And whatever I do to the denominator, I must do the exact same thing to the numerator. And to make 8ths into 24, so I'll need to multiply that 8 by a 3, because 8 times 3 is 24. And whatever I do to the denominator, I must do to the numerator. Okay, so my first step is get a common denominator. 5 times 4 is 20 over 24, plus 3 times 3 is 9 over the 24. So they've got the same denominator. So when I'm adding, the denominator stays the same if it's common, and then I simply add the 2 numerators. So I get 20 plus 9 on top, or in other words, 29 over 24. And there's no number that I can divide 29 by and 4 by other than 1. So that's in simplest form as well. Right? Subtraction, same exact way. First, we have to get a common denominator. So 3 and 5, a common multiple is 15. So to make thirds into 15s, I'll need to multiply by 5 on top and on bottom. And to make fifths into 15s, I'll need to multiply by 3 on top and on bottom. So 2 times 5 is 10 over 15. 2 times 3 is 6 over 15. And if I have a common denominator, that denominator pushes through, and I get 10 minus 6 in my numerator. So I get 4 over 15 for my common, for my answer. And since there's nothing that divides both 4 and 15 other than 1, it's also in simplest form. Okay, so hopefully that's a quick fraction review. my fancy panning technology. All right, so now we're going to do some simplification of polynomial expressions. It's a polynomial because all the powers of x, like x to the first, x squared, are whole numbers. So these are polynomials or rational functions, which is a polynomial divided by a polynomial. All right, so I'm going to simplify. So this first guy, and again, I would pause, copy these out, and then press play and work through it with me. So this first guy, I got a 3x times this quantity within parentheses. So I need to make sure my 3x multiplies into every part within the parenthesis first, okay? So I've got 3x times 8x squared. I've got 3x times 7x. I've got 3x times 2. I'm adding 5x, I'm subtracting 4, okay? All right, now 3x times 8x squared. Well, I can multiply the bits together that I feel comfortable multiplying together. This is all multiplication, so I'm going to take the 3 times the 8, that gives me a 24. The x times an x squared, that's an x to the first, so x to the first times x squared gives me x cubed. I add the powers when I multiply two x values together. Second one, I've got a 3 times a 7, so that's a 21. And an x to the first times an x to the first is an x squared. 3x times 2, that's 6x, plus, and I got my 5x and minus my 4. Okay. And then I note that I've got a 6x and a 5x. They're both x to the first. So I've got 6 copies of it here, 5 copies of it there. So I can combine those to be 11 copies of x. And then I've got a 24x cubed, a 21x squared. That was positive 11 of the x's, and then minus 4 at the end. So there is a cubic, a degree 3 polynomial, the highest power of x was 3. Okay. All right, I'm going to skip to this one. So when I have one linear polynomial, x to the first e, times another linear polynomial, another x to the first e, I'm going to implement FOILing. So that means I'm going to multiply the first terms together, the outers together, the inners together, and the lasts. Okay. So first terms, that's the x times the 3x. So let me just do it in slow motion, x times 3x. Plus the outers, that's an x times a negative 4. Plus the inners, that's a negative 1 times 3x. Plus the lasts, that's a negative 1 and a negative 4. Okay. All right, and then let's just simplify. X times 3x would give me a 3x squared. X times negative 4 would give me a negative 4x. Negative 1 times 3x would give me a negative 3x. And negative 1 times negative 4 would give me a positive 4. And again, I have two like terms. These are both x to the first terms. So I have negative 4 of the x's and negative 3 more of the x's. I have negative 7 of the x's. Plus 4, right? So that would be the FOILing out and gathering like terms. All right, then this third one here. I've got a rational function. I have a degree 2 polynomial divided by a degree 1 polynomial. And I'd like to simplify it. So I think maybe I always try and factor first and see if anything cancels. So in the numerator, I see both the 8x squared and the 6x has something we can factor out. We could factor a 2 out of both of them and an x out of both of them. So I'm going to factor out a 2x. When I factor a 2x out of 8x squared, I'm left with a 4 and an x, right? So if I multiply that back through, I'd have an 8 and an x squared. Minus. If I factor a 2 out of 6, I'm left with a 3. If I factor an x out of an x, I'm left with a 1, so 3 times 1. So when I factor out a 2x from the top, and we're left with 2x times 4x minus 3, all over 2x. And since multiplication is holding the 2x to the numerator, I can cancel it with the 2x in the denominator, and I'm left with a 4x minus a 3. Okay. All right, so one more quick panel to go. So in the last panel, we multiplied factored terms out. We expanded them. Now we're going to try and factor them. So something's been expanded, and I'd like to figure out the two pieces that multiply together to give me these two objects. Okay. All right. So again, I'd pause, copy this down, and press play while I talk through it. All right. So the first one, I'm looking to create two linear terms that when I multiply together, when I first out inner last it and simplify, I get x squared minus 5x plus 6. Well, to create the x squared, I'm pretty sure I need an x and an x. All right. When I multiply, whoops, it isn't there, x still. Doing cough. All right. The two first terms need to be x. So first would be x times x, which will give me the x squared. Now the last has got to give me the 6. So I could see that coming out as a 1 times 6 or a 2 times 3. Okay. It's the only way a product can give me 6. And then I've got to use, so I'm thinking here like a 1 and a 6, 1 and a 6, or a 2 and a 3 kind of thing, right? And then the outer and the inner terms have to add together to give me that 5. So a lot of choices here, a lot of guessing and checking, okay? And I also noticed one other thing. It's a -5 and a +6. So that means I've got to have a negative and a negative. The two negatives, when they multiply together in the last, will give me the +6. And when I add them together, I'll get a -5x, okay? So let me just do it wrong first, and then I'll correct it and do it right. Let me say I think it's going to be the 1 and the 6. So let's just do a check, okay? All right, so x times x would give me an x squared. Outer, x times -6 would give me a -6x. Inner, -1 times x would give me a -x. And last, -1 times -6 would give me a +6. So this would give me x squared minus 7x plus 6 when I simplify. And that's not what I started with. So that can't be right. So whammo, I've made a mistake with the 1s and the 6s. So let's instead try the other choice, which was 2s and 3s, -2, -3, okay? And I'll check. So first, x times x is an x squared, good. Outer, x times -3 is a -3x. Inner, -2 times x is a -2x. And last, -2 times -3 is a +6. And the -3x and the -2x will combine to give me that desired -5x that I started with, okay? So I'm doing trial and error. I'm guessing as to how it'll factor. I'm trying it, and I'm checking to see if I'm right, okay? All right, so this one would be incorrect. This one would be correct. All right, last but not least, I got another one to factor, but now it's a little bit more tricky. I'm starting with the 3x squared, not just a 1x squared. But let's see. To create the 3x squared, I'm thinking I have to have a 3x to start one of these off and an x to start the other off, okay? All right, and for the lasts, to create a 3, I'm thinking I could either have 1 and 3 or -1 and -3. I think that's the only way the last two numbers multiply to +3, okay? And I notice that I've got a negative sign on the 10x. And the only way I get a positive last term and a negative middle term is if I use the negative versions. So the question becomes, should I have -1 here and -3 here? Or should I have -3 and -1? Okay. And it'll matter. So trying to look ahead, I know I need to get my x's to add up to -10. So I think if I have a 3x and I get to multiply it by a -3, that gets me to -9 of the x's. And then I've got a -1 and an x to get me to that -10 of the x's. So I think I want this first alignment of a -1 and a -3. So let me try that and just check it to see I'm right. So I wanted a -1 here, I think, and a -3 here. I'm just going to check by multiplying it out and see that I get back to where I started. So foiling again, first 3x times x is a 3x squared. That's what I wanted. Outer 3x times -3 is a -9x. Inner negative 1 times x is a negative 1x. And last, negative 1 times negative 3 is a positive 3. So I think I'm getting 3x squared minus 10x. It's 3. Yes, so I know I'm right. Okay. So with these, you can always check to make sure you got the right answer. All right. So again, I need to see all of this copied down into your notes, and you'll be showing me this at the start of class. Thank you.